We have a thing in math called a trinomial square. It looks something like that. It can be written as a binomial square. Inside here will be two terms. And what I do is I take the square root of that, and I take the square root of that, and those are my two terms. Okay? You've seen something like that before? So if I have something like this, Jonah, I saw you nodding. I haven't been able to call on you for a whole week, so tell me what you would get here.
X squared minus 8x plus 16.
Plus 16. Okay? Would everybody agree?
Mm-hmm.
Okay? So there's a relationship between this and this, correct? In other words, if I wanted to find that 16, if I gave you this, it's got to be positive always, right? Because you're taking a number times itself. What has to go here?
The square root of 18.
How did you get 81?
Because it's half of 18 squared.
It's
Oh,
half of 18, which is 9, and then you square it, correct? Which means then I could put it into this form. Would you agree? Okay, and that form would be what, Ella?
X minus 9.
X minus 9, okay? So, when I used to teach algebra in solving quadratics, and I don't know if it's done anymore, and I had, where did I put my examples? I just set them here, and then I put them where? You gotta be kidding me. Oh, let's just do this. Rather than have to find solutions, right, where that parabola crosses the x-axis, rather than have people factor, because some people would find it, I would do a process called completing the square. So I would make this equal to 0, and I'd write x squared plus 12x equals a negative 32. And then I complete the square on this side. So to complete the square, Kellen, I would have to add what?
144.
Well, you have to take half of it.
Oh, 36.
Perfect. And then add 36. Okay? Because I'd have to add it to both sides, right? You understand that? And then this would become x plus 6 squared, and this would become 4. Everybody with me so far? And then I would solve, and this would have to be plus or minus 2, because 2 times 2 is 4, and a negative 2 times a negative 2 is 4, correct? And then I would subtract 6, and I would say, hey, I got two answers, a negative 6 plus 2, and a negative 6 minus 2. And I would come up with my negative 4 and my negative 8. Have you seen that before? Okay?
I think I have.
You think you have?
Yeah.
Okay. So, let's say we have something that looks like this. I'm going to hide for a second. And make that equal to 0. Do you see that okay, Audrey? All right. And I'm going to take 2x squared plus 7x. I'm going to make it equal to a negative 3. And then I'm going to divide by 2, and I'm going to get x squared plus 7 halves x is equal to a negative 3 halves. Everybody okay with that? Okay, now remember our rule. We take half of this, So my dad, didn't go to school beyond 8th grade. And so at age of 9, you know how I learned to cut something in half? He said, just double the denominator. So it's 7/4, correct? And then I gotta square it. So it's gonna be 49/16. And I'm gonna add 49/16 over here. Everybody doing okay? And then this is going to be x plus 7/4.
What?
Squared.
Quick question, why did you square it?
Because that's the process you do for completing the square.
Okay.
You take half of this and square it.
Okay.
Then,
Oh yeah.
then
yeah,
Kala
that makes
take
sense.
half of this and square it.
Yeah, that makes sense.
Okay. And then this is a negative 24 over 16 plus 49 over 16, and I get 25 over 16. Everybody with me?
Yep.
Okay? And so then I'm going to have x plus 7/4 equals the square root of this is plus or minus. Square root of 25 is 5, square root of 16 is 4. So my answer is going to be 7/4 plus 5/4, or 7/4 minus 5/4,
So either 2/4, aka a half, or 12/4.
which is,
Let me just think about that for a second.
no, it should be automatic, my favorite number.
Oh, sweet.
Yep. All the time. Okay? All right. One more I'm going to show you, completing the square. Let's say I have a negative 2x.
We can't see the entire thing.
You can see it now, right?
Yep.
Plus 8x I'm gonna make up a number, plus 17, okay? So what I can do is I could put parentheses around those two, correct? Okay, and then factor out a negative 2, and I get x squared minus 4x. Plus, I'm going to complete the square there. Ariana, what would I add? 4. I still have this plus 17. Would everybody agree? But I added something new in here. And this is where you got to be careful. This is not really an x squared, it's a negative 2x squared, correct? This is not really a minus 4x, it's really a plus 8x. This isn't really a 4, it's a what?
-8.
It's a negative 8. So I have to add 8 to this side to make it balanced, right? It's still the same as up here because I simply added 0, right? And then I can write it like this.
Shouldn't we be minus an 8 since it's a -8?
What's a negative 8 plus 8?
Oh.
0.
Yeah, I understand.
So I added 0, which means it's the same as this. Okay? So I'm going to get x minus 2 squared. Would you agree?
Mm-hmm.
Plus 25. Would you agree? And I could write this as 25 minus 2 parentheses x minus 2 squared. Would you agree with that? I can even go further, Audrey. I could write this. Correct? All right. Everybody okay with that algebra? All right. I'm going to hand out some notes. And I'm going to do 3 and 4 first, and then I'm going to talk about 1 and 2. So I'm going to kind of do it in a different order. So I'm gonna start with number 3. And it's a method we use to solve this integral. And right now we have no way to solve it because if it's a derivative, what should be there is 2x plus 6. Does everybody see where I get 2x plus 6? I took the derivative of the bottom. And since this is the derivative, the chain rule says that 2x plus 6 should be there. But it's not. So it's something different. So I'm going to complete the square. Since it's not, I'm thinking perhaps it's one of the trig inverses. Okay? So, right here I'm going to write x squared plus 6x. I'm going to put in parentheses, and I'm going to add 10 over here. So to make this a perfect square, Grace, what do I have to add? 9. So since I'm adding 9, I gotta subtract 9 over here. Because 9 minus 9 is 0, correct? Ben, what is the binomial square for this?
X plus 3 squared.
X plus 3 squared. Plus 1. Would you agree? So now I'm going to come back here and I'm going to write it like this. Okay. So I'm going to say u is equal to x plus 3 because it's in parentheses. I'm going to take the derivative. Colin, what's the derivative of x plus 3? 1. So it's going to be 1 dx, correct? Which is the same as dx?
Yeah.
Everybody okay with that? So now I can come back here and I can substitute. I got 1 over here. I got u squared here, plus 1 du. So du went in for dx, u went into for x plus 3, and can we see what inverse trig it is? Is it, we're basically only been working on 2, correct? Because I'm not going to test you on the secant inverse. Matthew?
Tangent.
So it's going to be tangent inverse of u plus c. So it's going to be the tangent inverse of x plus 3 plus c.
So my guess is number 4 is going to be the inverse of sine.
I'm thinking, let's see if we can get there. Okay? So I'm going to, on the side, I'm going to write minus x squared plus 8x minus 15. I'm going to group these two. I'm going to factor out a minus sign. And I'm going to have x squared minus 8x. We're going to leave a little room. It's going to be plus something. And over here I got a minus 15. Audrey, what do I add to complete the square? 16. So, am I going to have to add or subtract 16? It's already a negative, isn't it? Because there's a minus sign here, correct? That's what you got to be careful of. It's already a minus, so what am I going to do with, because you said oh, add it. So now, this is the same as this. Would everybody agree? So inside my integral, it looks like this, 1 over square root 1 minus x minus 4 squared dx. Now, I'm going to take a jump here. See if you can follow. I know u is going to be x minus 4, correct? I know the derivative of that means du is going to equal dx, correct? Because you get 1. And in my brain I see 1 minus u squared du, correct? So that's going to be sine inverse of x minus 4 over 1, correct? Which is just x minus 4 plus c. Do you want me to write the u substitution, or are you okay with me?
I understand.
You understand? Okay. Everybody okay on that? All right. The other part is long division.
We haven't done that in a while.
Yep.
Time that we remember how it works.
And I'm going to show you.
Yay.
Okay? Now, you only do long division when this happens. When you have a binomial on the bottom, it means you have two terms. And if you look at, you guys know what I mean by a degree of a polynomial?
Did you
Tyler, what's the degree of this top polynomial? How did you know that? It's the highest exponent, correct? What's the degree of the lower polynomial? 1. So anytime you have a greater degree on top than on the bottom, you want to do long division. And I'm going to write that right above here. Long division when degree on top is greater than degree on bottom. So here's my long division. The x minus 2 goes on the outside. And I have 3x cubed minus x squared minus 5x plus 1. And I look at this first term. What can I multiply this term by to make it 3x cubed? Matthew?
3x. Oh, yeah, 3x cubed. 3x squared.
3x squared. Everybody agree? So I write 3x cubed underneath because 3x squared times x is 3x cubed. But this is a binomial. So I got to multiply the minus 2 by the 3x squared also. And I get a minus 6x squared. Everybody cool on those two terms? Now, Callan, I'm going to admit something to you. When I learned long division when I was in high school, I sucked at it. I could do this part, but I couldn't eliminate. And my favorite math teacher was a guy named Mr. Eckstein. He says, because I had issues with negative numbers. I'm great at adding, not so good at subtracting. He said, just change the opposite signs and add. And I've been doing that ever since because 3 added to a negative 3 is 0. And so when I add this, I get 5x squared. Everybody okay on that? And then I bring down the next term. So it's a minus 5x. Now, Ben, Owen's not here, you know that? So you gotta answer for him,
Alright.
okay? So if you make a mistake, it's Owen's fault. What do I multiply x by to make it 5x squared?
Negative 5x.
It's gotta be the same sign,
Oh, 5x.
5x. So plus 5x. Then when I take that 5x times a negative 2, what do I get, Ben?
Negative 10x.
negative 10x. So I make sure that these two are the same degree, okay? Or excuse me, the same sign. Yeah.
Yeah.
Okay, so now is when I change the signs and add them. So I get 5x plus 1. Owen, through Ben, you did a good job. Maria, what am I going to multiply x by to make it 5x? 5. So I got plus 5, I get 5x minus what? 10. Change the signs, add, I get 11. Everybody okay with that? So now I'm going to change this integral, and I'm going to change it to this. 3x squared plus 5x plus 5, because that's my quotient, plus the remainder, which is 11 over x minus 2 dx. So I take this remainder and I put it on the divisor. Just like when you take, let's say I have 17 over 5. That goes in there 3 times, I get a remainder of 2 and I have 2/5. Remember doing that a long time ago? Okay, I'm doing the same thing here. Now, I'm going to break it up into 2 integrals. And I can bring the 11 out, can't I? Right? Does everybody see that? I can bring the 11 out because 11 times 1 over x minus 2 is 11x. 11 over x minus 2. All right. We should be okay of taking the antiderivative of this. Okay? Jonah, what's the antiderivative of this?
X to the third,
Perfect. Plus?
5 over 2x squared,
Perfect. Plus?
5x.
5x. Everybody agree with that? That's just reversing the power rule, right? Now, I haven't done this for a long time. There's a 1 there, correct? It's a negative 1, correct?
ln.
So I'm thinking ln, correct? Is the derivative of x, where am I here? X minus 2, is it the derivative of x minus 2, 1? It is, isn't it? So this is going to be plus the natural log, absolute value, x minus 2 plus c, and I'm done.
What about the 11?
Oh, I forgot the 11. 11 times. Thank you. God, I would have given myself 0.2 of a point off for forgetting that 11. Maybe 0.1. Depends on what I'm feeling.
I think I understand it.
Okay, let's find out. Audrey, is the degree on top bigger than the degree on the bottom on number 2?
Yes.
Yes. So outside here goes 3x minus 5. Would you agree, Audrey? And inside here goes 6x to the 4th minus 7x cubed plus x squared plus 2x plus 0. Would you agree with that?
Yes.
Audrey, what can I multiply 3x by to make it 6x to the 4th? 2x to the 3rd. What am I going to write down below here? 6x to the 4th, right? Is that what you said?
Yes.
Minus
10x to the 3rd.
10x to the 3rd, perfect. Change the signs. Add. Audrey, do I get a 3?
Yes.
And I have another 3?
Yes.
Isn't that marvelous? Wow. And I'm going to bring down the plus x squared. Okay, Audrey, am I going too fast?
No.
So I'm going to write a plus sign. What am I gonna multiply three x by to make it three x cubed?
X squared.
X squared. I get three x cubed minus what?
5x squared.
Five x squared. Take. What do you get here? Do I get six x squared
Yes.
plus two x?
Yep.
What am I going to, why did I write a 4, Audrey? Because I'm nuts. All right. What can you multiply 3x by to make it 6x squared?
2x.
2x. 6x squared. Minus what?
10x.
10x. Change signs. Add. Can I get 12x?
Yes.
Is that right?
Yep.
Can you multiply 3x by something and make it 12x?
Yes.
What?
4.
4. I'm not a fan of 4, you know that? Change signs. Do we get 20 as our remainder?
Yes.
Colin, is that correct?
Yes.
Okay, Colin. We're gonna integrate. We're gonna write 2x cubed plus x squared plus 2x plus 4 dx. Are you okay with that?
Yeah.
And since I have an issue with spacing, I got another integral. It's going to be 20 over 3x minus 5. Do you agree with that?
Yeah.
So I'm going to bring the 20 out, and I'm going to write 1 over 3x minus 5 dx.
We take the antiderivative now?
Well, I want to make sure Colin agrees with me. You have a look like I did something wrong, or I need to explain. You're okay with it? Because it's 20 over 3x minus 5, but it's 20 is a constant, so always bring them out. And you'll see why in a second, okay? All right, so now we're going to take the antiderivative of this. Callan, the antiderivative of 2x cubed.
2/3, wait, no, 1/2.
Ooh,
x
good,
to the
you
fourth.
did a nice switch. 1/2 x to what power?
It's a fourth.
Perfect. What about this next one?
2x. Or,
Uh,
no, 2. X to the, no, 1/3 to the x over. X to the third.
Right. Notice how you said 2x? That's not, you would not have been in trouble with Norm because that's just a little bump. Okay? You wouldn't have even noticed a little bump. Plus what?
X squared.
Yeah? Plus what?
Two. Or just dx. Right?
Yeah, it's gonna have, but you need a 4 once you take, if you took the derivative of x, you would get 1, correct? The derivative of what will give you 4?
So I'm lost.
Okay? Let's say I have x, okay, f equals x. What's the derivative of that?
Just
1, correct? You agree? So if I have f equal 2x, what's the derivative of that? 2. Perfect. What if I have 4x? What's the derivative of that? 4. So the antiderivative of 4 must be what? 4x. Okay? All right. So over here I have 4x. Everybody agree with that? Yes.
I believe I have the answer.
Can you wait for a little bit? I want to do some explaining. Okay? Now, well, let me spin off that. Okay? Did you realize that that is to the first power?
Yes.
And so, in your mind, did the gong go off?
Yes.
Okay.
I saw
So,
the 3, so I
just
got
wait, just wait. So, I'm thinking natural log like you are. Correct?
Yes.
So I look and I see that the derivative of this is a what?
A
A
three.
3. A 3 must be up there.
It is
Well,
not.
what I'm gonna do is I'm gonna put it there. But I gotta divide by 3. Because you got 3 over 3 and now you haven't changed anything, have you? Is that making sense to everybody?
I did not put the plus, put that other 3 in, I did the 20 divided by 3 because that's what we did, yeah.
Yeah, and that's A-okay.
You just added extra steps.
Right. So this is going to be plus 20 over 3, the natural log of 3x minus 5 plus c. So if I would take that derivative, the 3x minus 5 would go on the bottom, the 3 would go on top, correct? And I'd multiply it by 20 over 3, the 3's would eliminate, wouldn't they? And 20 would be on top. Is that making sense to everybody?
I think it does.
Okay. So it's all of this right here. Okay, everybody okay on that? All right, I want to do one more thing. Yeah, I'm gonna do, well, what time are we done?
45.
45? Yeah, I got time to do this. I'd rather do this and get caught up.
We have one more back.
Oh, there's something on the back?
Wait, what?
Oh, look at this.
I don't see anything on the back. Anyone else see anything on the
No, I
back?
don't got it. I don't have anything on mine.
We're gonna turn this into a tangent, into an inverse tangent.
All right. Why are you thinking inverse tangent?
Because we're not doing long division.
Why aren't you doing long division?
Because the degree on top is a 0.
Would everybody agree? All right, so let's take a look at this. Plus what, Austin?
4.
Perfect. So what do I gotta do over here?
You would subtract 4.
Perfect. So this is gonna become something squared, correct?
Yeah, x minus 2.
Perfect. And what is
16.
16? So I can rewrite this as this. I'm gonna bring the 32 out. Why? Because it's a constant. I'm gonna have 1 up here. I'm gonna have dx right here. I'm gonna write x minus 2, and I'm gonna write plus 4 squared. There should be squared also. So this is my function. Is the derivative of this 1?
Yes.
This is a, isn't it? Okay? And if you remember, tangent inverse is, I believe, 1 over a times tangent inverse of the function g of x over a. Am I right?
Heck if I know.
It's in your notes, I believe that's true.
I haven't looked at those notes in a while.
Okay. So, it's going to be 32 times 1 over 4 times tangent inverse of
X minus 2 plus C.
x minus 2 plus c, or 8 times the tangent inverse of x minus 2 plus c. Okay?
Yeah.
Alright.
Makes sense.
Okay, this is the last, it won't take very long.